right, so we've looked at parallelograms. Now we're going to take a look at quadrilaterals. So our question for today is, how can we use the properties of a quadrilateral to solve for the unknown? So we're going to go through properties of rectangles, properties of rhombus, and properties of a square, and then solve some problems using those. So these are all types of quadrilaterals. A quadrilateral means a four-sided shape. So rectangles. A rectangle is a parallelogram with four right angles. A rectangle has all the properties of a parallelogram plus four right angles, and the diagonals are congruent to each other. So we got four right angles that I'm sure you knew. This side and that side are parallel, this side and this side are parallel, and opposite sides are congruent, and the diagonals are congruent as well. A rhombus. A rhombus is a parallelogram with four congruent sides. A rhombus has all the properties of a parallelogram plus four congruent sides. Diagonals bisect each other, and they bisect the angles, and the diagonals are perpendicular. So we have a diagonal here, and we have a diagonal here. Rhombus, the diagonals are perpendicular to each other, and the diagonals bisect each other. So this angle is congruent to this angle, that's congruent to this angle, that's congruent to this angle. And this angle is congruent to this angle, that's congruent to this angle, that's congruent to this angle. So all four of these are the same, and all four of these are the same. And the last one that we're going to dive into is a square. A square is a parallelogram with four congruent sides and four right angles. A square has all the properties of a parallelogram plus all the properties of a rectangle and all the properties of a rhombus. So a square is a rhombus and a rectangle. It's just a special type of rhombus and rectangle where all the sides are the same, all the angles are four angles, all the angles are right angles, So a square is a rhombus and a rectangle. Now let's go for it and jump into and see what kind of things we'll be expected to know. All right. Example 1. Solve for x and the measure of each angle if DGFE is a rectangle. So they're telling us that DGFE is a rectangle. So we're going to keep that in mind. So I know that if 9x minus 6, if this little section right here is 9x minus 6 degrees, and this little section right here is 2x plus 8 degrees, angle E is a right angle. Since angle E is a right angle, I can add these together and set it equal to 90. So 9x minus 6 plus 2x plus 8 is equal to 90 degrees. We can go through and solve this problem, combine like terms. Subtract 2 from both sides. And divide. I got 88. And the question also wants us to, what else does it say? Find the measure of each angle. So I can find the measure of angle DEG. So I can find the measure of angle DEG. So that is DEG. So this little section right here. And I also can find the measure of angle FEG. So what you would need to do is take 88, substitute it in for this x right here, and substitute it in for this x right here. So you will need to do 9 times 88 minus 6, and then 2 times 88 plus 8. So the measure of angle, not 88, excuse me, just 8. My apologies. I'm sure you're probably home thinking about what in the world. So 88 divided by 11 is 8. So my apologies. So you're going to need to do 9 times 8 minus 6. And then 2 times 8 plus 8. So the measure of angle DEG is 66. And the measure of angle FEG is 24. All right. So you probably knew that well before today anyway. So the rectangle, 90 degrees, set those equal to 90 and solve, and then substitute them back in. So that one wasn't too bad. Hopefully it wasn't too bad. All right, example 2. ABCD is a rectangle whose diagonals intersect at point E. So I can put point E in here. Part A, if AE is 36 and CE is 2x minus 4, find x. And then part B, if BE is 6y plus 2 and CE is 4y plus 6, find y. So let's do one thing at a time. I know that rectangles, their diagonals are congruent to each other. So I know that AE is congruent to CE. So we can put our tick marks up here, because I know that they are congruent to each other. So it says that AE is 2x minus 4. And I know that CE is AE is 36 and CE is 2x minus 4. So I can set those equal to each other. So from here to here, that part is 36. And from here to here, that part is 2x minus 4. So we will set this equal to each other, solve the equation, you'll get 20. Now let's do part B. BE is 6y plus 2. So BE is 6y plus 2. CE is 4y plus 6. So I also can set these equal to each other to figure out what y is. So BE, and this is supposed to be DE there. Okay. So that is a D. So I know that BE is 6y plus 2 and DE is 4y plus 6. So I can set these equal to each other. Go through, solve the equation, we get 2. So I use the theorem that rectangles, their diagonals are congruent. So diagonals congruent. So that's what I use to help us solve this. So in a rectangle, the diagonals are congruent to one another. And even before this typo here, even if that was a CE, I could have set these equal to each other too, because all the parts are congruent to each other. So if I come back up here to this rectangle, all these segments are congruent to one another. So yes, these two are congruent and these two are congruent, but all 4 parts are congruent to each other. So back down here, regardless of if this was DE or CE, so regardless of if this was DE or CE, all 4 of these segments are congruent to each other because they're rectangles. So again, regardless of if this was DE or CE, all 4 of these segments here are congruent to each other. So I could have set these 2 equal to each other or these 2 equal to each other to find the proper answer. All right, down at the bottom. Use the diagram to the right to answer the following if ABCD is a rhombus. So now we're looking at our rhombus section. Things we know about rhombus. A rhombus is a parallelogram with 4 congruent sides. A rhombus has all the properties of a parallelogram plus 4 congruent sides. Diagonals bisect the angles, and the diagonals are perpendicular. So we're using this figure here to help us with A, B, C, and D. Find the measure of angle 1. So the measure of angle 1 is going to be 90 degrees. How do I know that? Because diagonals are perpendicular. So that's a property of a rhombus that we know. B, find the measure of angle 2. So if this is 58, this space here must also be 58 because these are alternate interior angles. And alternate interior angles are congruent to each other. So this little section here is 58. Alternate interior angle is angle 2, so they are congruent to each other. C, find the measure of angle 3. Measure of angle 3 is also 58 degrees, so that's this angle right here. How do I know that? Because diagonals bisect the angles. So this diagonal is a bisector. We just found that this side was 58, so this side must also be 58. And D, find the measure of angle 4. We can do that by doing 180 minus 90 minus 58. So I'm looking for an angle 4. I know that this is 58. I know that this is 90. If you add up all the degrees in a triangle, they add to 180 degrees. So just do this simple calculation, and we know that it is 32 degrees. So those are all things about a rhombus that we should know. 4 congruent sides, the diagonals bisect the angles, and diagonals are perpendicular. Okay? Moving on over, now we're going to take a look at some more with rhombi, which is the plural for rhombus. Example 4. Solve for each variable if the following are rhombi. So since they are rhombi, I know that these two sides are going to be congruent to each other, and I know that these two sides are going to be congruent to each other. So 4x plus 3 is equal to 15. Solve this equation, subtract 3, divide by 4, I get 3. And I know that these two are equal to each other. 3y is equal to 5x. We're going to take 3 and make a substitution into our problem. So 3y is equal to 15. And 15 divided by 3 is 5. Okay, so that's that one. Moving on to B. Same thought process here. I know that these two are equal to each other and these two are equal to each other. So we can do 2y minus 5 is equal to y minus 1. Solve your equation, you should get 4. And we know that the other sides are equal to each other. So 2x minus 7 is equal to 3y minus 9. Since I have two different variables here, I got an x and a y, we want to make our substitution that we just found in the previous problem. So 2x minus 7 is equal to 4 times 3 is 12. So that's going to give me 12 minus 9. 2x minus 7 is equal to 3. Add 7, you get 10, and divide, you get 5. So both of these problems, I know I solved the equation kind of fast or whatever. We've been solving equations for a while, opposite operations. But you should know that the top and bottom are congruent to each other, and the two sides are congruent to each other. Again, the top and bottom are congruent to each other, and the two sides are congruent to each other. And we're going to end with some properties of trapezoids. So we've done parallelograms, we've done quadrilaterals. We're going to take a look at some trapezoids. By all means, I am going to read through these, but make sure you take a picture or take notes, whatever you need there. Right here on the side, it says a trapezoid is a quadrilateral with exactly one pair of parallel sides called bases and two non-parallel sides. If I have an isosceles trapezoid, an isosceles trapezoid is a trapezoid with congruent legs. A trapezoid is isosceles if there is only one set of parallel sides, base angles are congruent, the legs are congruent, the diagonals are congruent, and opposite angles are supplementary. And we have a picture down here that says everything that I just read out loud. One set of parallel sides, the base angles are congruent, the legs are congruent, the diagonals are congruent, and opposite angles are supplementary. So this plus this is 180, and this plus this is 180. The trapezoid mid segment, right here. The median, also called the mid segment of a trapezoid, is a segment that connects the midpoint of one leg to the midpoint of the other leg. Theorem. If a quadrilateral is a trapezoid, then A, the mid-segment is parallel to the bases, and B, the length of the mid-segment is half the sum of the length of the bases. So MN is parallel to TP. MN is parallel to TP. MN is also parallel to RA. So by definition, we know this formula is going to hold true. And we're going to go through and solve a problem dealing with that formula. So I got 4 examples that we'll go through dealing with trapezoids. So CDEP is an isosceles trapezoid, and the measure of angle C is 65. What's the measure of angle D? What's the measure of angle E? And what's the measure of angle F? So the measure of angle C is 65 degrees. Since this is an isosceles trapezoid, if this is 65, I know that this is 65 also. So 65 degrees. Now, I know if I add them all up, it's going to give me 360 degrees if I add it all up. So what you could do is, and you also know that we have some supplementary angles in here. So I could do 180 minus 65 to get 115. So I know that this side is 115, and I know that this side is 115. So there we have it. So measure angle D is 115. The measure of angle E is 115. And the measure of angle F is 65. So I know if you add all four of these up, it'll give you 360. So you could have went that route. But I also know that these two are supplementary and these two are supplementary, which is why I did the 180. Example 6. What are the values of x and y in the isosceles triangle below if DE is parallel to DC? So DE is parallel to DC. And that, let me see, DE is parallel to DC. This is a typo here. It's telling us that DE is parallel to BC. So that is a typo there. My apologies. Okay. So this is not my note sheet. It's just something that I'm using because I thought it was a good note sheet to have. So DE is parallel to BC. So here we go. I know that I can set up an equation and I can find the big triangle. So my big triangle would be angle A, angle B, and angle C. I have an isosceles triangle, which means that these two angles here are equal to one another. Whatever this is the same. So I can set up an equation. 32 plus 2y is equal to 180. So I'm looking at the big triangle, angle A, angle B, and angle C. If I add up those three angles, they're going to add to 180 degrees. So I got that y was 74. Now, this is 74, and this is 74. Now, if I'm looking for x, I know that these two are supplementary angles. X and y are supplementary angles. Because I got a parallel line and a parallel line cut by a transversal, these are consecutive interior angles, and consecutive interior angles sum to 180 degrees. So we can do 180 minus 74 to get to what x is. So x is equal to 106. All right. So we used the fact that we had parallel lines. So I looked at the big triangle to add everything up to 180, and then these two are supplementary angles. Last one. QR is the mid segment of a trapezoid, LMNP. What is X and the length of the side down there at the bottom? So we're looking for a side LM. So we're going to find the length of LM. So the first thing that I'm going to do, I know this top section is 4x minus 10. So if I take that and add it to the bottom section and divide it by 2, it'll give me this middle section right here. So I got that formula from right here. It tells us to add the top and bottom. So TP plus RA. Add the bottom with the top and divide by 2. So again, add the bottom with the top and divide it by 2. So I'm going to add the bottom. And actually, I'm doing the top first, but it doesn't matter. Bottom, top, top, bottom. We're going to add the two bases here. So 4x minus 10 plus 8. And we're going to divide it by 2. And that is equal to the middle section. So add the top and the bottom, divide it by 2, and that's equal to the middle section. Add the top, add the bottom, divide it by 2, that's equal to the middle section. So how do I solve this equation? We're dividing by 2. We need to multiply both sides by 2. Make sure you do the distributive property. Subtract 2x from both sides. Add 2 to both sides. And I got 3. And it wants to know what is the length of LM. So that's what got cut off a little bit here. So what is the length of LM? Where we're going to take 3 and plug it in. So LM is 2. So lots of information here, but feel free to use your theorems and different things that you wrote down to help you solve your problems and figure out if it's dealing with a parallelogram, a quadrilateral, or a trapezoid.